won't be going very fast, but we'll be having a whole lot of fun. Alright, so I'm going to ask if any of you ever seen a vehicle quite like this before. You've ever seen a lot of shaking heads back there? Oh, that's probably because there's only 23 of them in the entire world. Does anyone have a guess how many we own here at the Columbia Icefield?
20?
You guys are close. We own 21 of them. There's also one owned by the American government. It's stationed down in Antarctica, doing some pretty cool research. And the last one is owned by the Australian government. So this Ice Explorer is designed to handle all types of steep terrain. If you ever been driving down the highway and seen one of those signs indicating that there is a steep road ahead, well, those signs indicate a grade of anywhere between 6 to 10%. This Ice Explorer can actually handle a grade of up to 36%. And the hill I'll be taking you down in just a few minutes here is currently coming in at a 29% grade. So yeah, it's pretty steep. As well as being able to handle all kinds of steep terrain, this thing's also pretty good on the ice. Kind of like the ice road heading up to the Athabasca Glacier, which is where we'll be heading today. The Athabasca is an outlet glacier coming off of the Columbia Icefield. You might be wondering, well, what's the difference between an icefield and a glacier? Sit back, and I'll paint the icy picture for you. An icefield is like a giant lake of frozen snow that sits really high in the Alpine Valley, like all the way at the top of those mountains up there ahead of us. It takes about 4 to 5 years and the pressure of 40 to 50 meters of snow to make just one layer of glacial ice. These layers of glacial ice will stack up for years and years and years, like literally tens of thousands of years. Eventually it's piling up so high that there's no choice but to spill over into the valleys below. Kind of like when you overflow a glass of water. When that ice overflows into the valleys below, that is how we wind up with outlet glaciers. In order to be considered an icefield, there must be at least 2 outlet glaciers. Our Columbia Icefield, being the largest icefield in North America, went ahead and created 6. With our Athabasca being one of those 6. And speaking of our gal Athabasca, there she is right up in front of us. Isn't she beautiful? An icefield is like that giant lake of frozen snow. And the easiest way to think of these glaciers are kind of like the frozen rivers that flow off of them. You might notice that I use that word flow there. That is because, yes, these glaciers do move. We estimate our Athabasca moves about 20 to 30 centimeters every single day. And as she moves, you kind of grind up all the rocks underneath and just shove them off to the side. That's how we end up with these large piles of loose rock and dirt that you might have noticed on either side of us. These large piles of loose rock and dirt are what we call moraines. Moraine being a fancy old French word, which loosely translates to, get this, a large pile of loose rock and dirt. There are a few different types of moraines starting off, going all the way out the right side of the bus across the valley there. You guys see that really steep ridge over there? Well, that is one of Athabasca's lateral moraines, and we're currently driving on the other one. These lateral moraines are a fantastic indicator of just how big our gal Athabasca was when she was at her largest. At that point in time, roughly 10,000 years ago, you could have walked from where we are now, all the way across that valley, without having to go downhill. This whole valley was filled with ice. The reason I'm telling you so much about the lateral moraine right now is because I'm actually about to drive you down it. Everyone excited to go down that steep hill? Yes. I just have to stop there to engage a couple of additional safety features. And while we make our way down, in the interest of safety, I will not be speaking. You guys are welcome to chat amongst yourselves. I just won't be able to answer any questions until we get to the bottom of the hill. And we'll resume the commentary once we're on mostly flat ground. guys get warm or want a better picture, the window should open a small crack. Feel free to open them.
Your window opens in
slowest roller coaster. So we have a guess what kind of crazy speeds we were getting coming down the hill there? Well, we're going around 4 kilometers an hour coming down that hill. No, it's pretty quick. So now that we have made it to the bottom of the hill, if you guys will believe it, we are actually driving on the glacier. Sure don't look like a glacier. No, it looks like a dirt road. Let me tell you, this is our ice core moraine. As that mountain off to our left erodes, it will cause these rock slides which come tumbling down the hill and cover the glacial ice in a layer of rock and dirt. This is the layer that we're driving on. It is about 1 meter thick. So yes, 1 meter below the tires of this bus is that glacial ice. You might notice that we are still a lot higher in elevation than all of that visible ice off to the right. And that's because this layer of rock and dirt that we're driving on works as a protective layer, preventing the sunlight from getting through. So that the ice in the ice core moraine ends up melting much slower. Here's like an excellent visual example of this. Take a look at the right side of the bus here. See this dirt pile? We can kind of see the strip of dry rock and dirt at the top. And then below it, you can actually see the blue and white of the ice just kind of shining through there. Well, that is identical to the terrain that we're driving on. So in just a minute here, I will be taking us out onto the actual glacial ice. After all, I know that's what you guys came here for. But before we do that, we have to go through the scariest part of the entire tour. The puddle. Nah, I kid. So this puddle is what we call our tire wash. Anyone have a guess why we might want to wash the tires before we head out onto the ice? Someone mentioned traction back there, and yes, it does help a little with the traction, but the main reason that we do it is because we want to rinse off any rock and dirt that those large treads of the tires happen to pick up. While that thick layer of rock and dirt in the ice core moraine works as a protective layer, when you have just a thin little layer of rock and dirt, it has the opposite effect and kind of attracts the sunlight, so it winds up causing the ice to melt much quicker. We call this the albedo effect, and it has a very similar effect to wearing a black t-shirt on a hot sunny day. I'm sure we've all made that mistake before. Now another thing that causes the albedo effect that you might be able to see around this is this kind of brownish or black tint to all the ice. That is what we call cryoconite. Now cryoconite is completely natural. It is a mixture of volcanic ash, smoke from forest fires, and dust from rock slides. That cryoconite sits throughout all the layers of the glacier and is very useful as a sign of the history of the ice. However, as the ice melts over time, cryoplanite does wind up sitting on top, and because it's darker in color, it will cause the ice to melt faster. I'm going to tell you about two more features of our beautiful glacier before I let you off the bus, and those are her crevasses and mill wells. Now, a crevasse is like a really large crack in the ice. As the ice moves over time, sometimes parts of it will move faster than others, and when this happens, it will cause the ice to separate, and these large cracks will form. Now, mill wells, on the other hand, are caused by this melt water. You might see it running down either side of the road there. Sometimes that melt water will pool in one particular spot. Actually, we have a little avalanche coming down the side of the cliff there. You guys see that? That might happen a few times today. Keep your eyes peeled in that kind of general area while you're out there. You might catch another one. Yeah, those mill wells are formed by the melt water. It will slowly dig its way down into the ice because water is warmer than ice. And you might be wondering why I'm telling you about all these really scary parts of the glacier right before we go out onto the ice. Let me tell you, there is good reason for that. These are very real hazards, and we do our best to make sure that you are safe from them. You will notice that there's these little red signs all over the place. These indicate our boundary area, and I need you guys to stay inside those signs. Those crevasses and mill wells that I mentioned are very real hazards that exist outside of those signs. However, we've made sure to inspect the area inside the signs to make sure that it's safe for you. I will also ask that you guys do not walk behind the buses. These buses have very large blind spots. If you were standing behind it when one of them went to back out, I promise you that driver won't see you. You are welcome to take pictures along the side of the bus. Just stay in front of the very back tires. Yeah, that is what we call one of our Kentucky tours. They like to come up here and take most of their clothes off. I don't have an answer for that. Alright, if you guys have any questions about anything other than the Kentucky tour, or have any of you drink the glacier water? I got a taste.
Yeah, it
We
was
also
great.
call that water the fountain of youth. It might take about 2 weeks to kick in, so if you're not noticing the effects right away, just give it time. There for about half an hour. But can you imagine? Definitely not my preferred type of camping. However, for a fellow by the name of Norman Colley, back in the 1890s, he wound up doing exactly that. Mr. Colley came here all the way from Europe, searching for two mountains named Hooker and Brown, which were rumored to be taller than Mount Everest. This turned out not to be accurate. Our mountains are about half the elevation of Mount Everest. However, Mr. Colley was not disappointed because he wound up discovering our Columbia Icefield. Mr. Colley came here from Europe and summited that mountain there to our right, Mount Athabasca. And when he got to the top, he was blown away by the amount of ice he saw. He then made his journey back down the mountain and spent 2 days and 2 nights on his journey to hit the airport to stand on the Columbia Icefield. When he got there, he was again blown away and was quoted saying, "A new world has spread under our feet." Along with discovering and naming the Columbia Icefield, Mr. Colley is also credited with summiting 21 mountains in our area and naming 30. This includes Mount Everest. Without Mr. Colley's discoveries, it is very unlikely that we'd be here on this tour today. So back when Mr. Colley was here, the glacier was significantly larger than it is now. In fact, it used to stretch all the way down past the Discovery Center, where you started your journey today. At this time, I estimate the glacier would have been around 8 kilometers in length, whereas nowadays it is down to around 5. Now we've lost 3 kilometers of ice in that time, we've also lost somewhere between 100 to 150 meters of depth. Even though we've lost quite a bit of ice, you are still standing on over 200 meters of glacial ice out there. That's about double the height of the Big Ben in London, for reference. You also might have noticed while we were out there that some of the ice had that more blue tint to it. And that is actually because of the density of the ice. As the weight of all of that ice on top pushes down, it'll push out the air bubbles down in the lower layers of the ice, that lovely blue color. If you look at the air in your freezer at home, that is typically about 50% air, whereas the air in, or the ice in our... Now in just a moment here, we will be heading back up the lateral moraine. And same as the way down here, roughly speaking. However, this time I wanted to point out a couple of things you guys can look out for. Those of you on the left side of the bus will have a beautiful view of upper and lower Shinwalker Lake. These lakes are entirely glacial fed, and an interesting fact is that the glacier has been melting so fast in the last 10 years that that second lake is actually new. Now those of you on the right side of the bus, normally you're feeling left out here, this area off to the right is what we call passable times of day. To keep your eyes peeled, you might even catch one or two. Alright, I'll resume the commentary at the top of the hill. partnership with some scientists from NASA. These NASA scientists come out here year after year to test these prototypes of some robots that they will soon be sending to one of Saturn's moons. This particular moon of Saturn has a very icy environment, very similar to our Athabasca Glacier. So NASA likes to come out here because, well, it's a little easier than going all the way to Saturn. They were out here last year testing this kind of snake-like robot, which was sent down into our crevasses to see how it can handle exploring the terrain. So far their tests have been a great success, but we've been told they will be back this summer to do a little bit more testing. A fun fact on the topic of NASA, there are actually less people authorized to drive these ice explorers than there are astronauts. So if you guys want an autograph, just let me know at the end of the tour. Another group of scientists who are out here pretty regularly are our glaciologists. These glaciologists are scientists who study the glaciers, and they come out here year after year to take samples of the ice to see how it's changing over time. They also like to take samples of the cryogonite because it contains a wonderful history. our glaciologists. So we are very grateful for everything they share with us. I know one piece of information that they gave us in the last few years, which I find extremely alarming, is the fact that our glacier is likely going to disappear entirely in the next 50 to 80 years. Because of this, we at the Columbia Icefield are doing everything that we can to try to be as sustainable as possible and save our glaciers. This includes things like these modernized buses, like this beautiful Mercedes bus that you're riding in right now. In fact, we're actually working on modernizing the buses to the point of building a fully electric Ice Explorer. We've been building this electric Ice Explorer down in Calgary, Alberta for about 2 years now, and we've been told that it's almost done. So we are hoping to receive it sometime this summer. If you're wondering why it matters that we make these efforts to save our glaciers, that is because the ice fields and glaciers worldwide actually hold 75% of the world's fresh water. They kind of act like giant frozen water towers, slowly releasing water here in Canada for millions of people to drink. And over in the Himalayan mountains, their ice fields release water for billions of people. This water is not only useful as drinking water, it is also used in many different industries. Here in Canada, the water that flows west from our ice field will travel through the Columbia River system all the way out to the Pacific Ocean, and on its way there, it will travel through 9 hydroelectric dams, providing power for millions of Canadians. The water that flows east from here.
The mountain snowdome. If you have a look at the top of that mountain, you'll see a thick layer of ice. It looks a bit like icing on a cake. That's the Columbia Icefield right there. And where we can see it, it's about 100 meters thick, so just about as tall as Big Ben is in London. Now, Snowdome Mountain is pretty special, not only because it holds up part of the Columbia Icefield, but also because it is known as a triple continental divide, and it's the only one of its kind in the world. What this means is that the meltwater that flows from the top of that mountain flows into 3 separate oceans. It's supported by 34 steel rods that go 16 meters into the mountains.